The National Electrical Code, or NEC, dictates that a main bonding jumper must be appropriately sized for the unbalanced load it carries. This is because the main bonding jumper serves to equalize the electrical potential between the neutral and ground conductors within an electrical system. If the main bonding jumper's capacity isn't sufficient for the unbalanced load, it presents a risk of overheating, potentially leading to a fire hazard. Using the main bonding jumper as a current carrying conductor for an unbalanced neutral load is permissible only if it adheres to the sizing requirements mandated by the NEC. Therefore, if the main bonding jumper is appropriately sized and properly connected to the neutral bar within the load center, it meets the NEC requirements. However, non-compliance occurs if the jumper size is inadequate to handle the unbalanced load. In practical terms, the unbalanced load refers to the maximum current that is expected to flow through the neutral conductor under normal operating conditions. This current arises due to differences in the loads connected to each phase of a multi-wire branch circuit or a three-phase system. The NEC provides guidelines and formulas for calculating the minimum acceptable size of the main bonding jumper based on the size of the service entrance conductors. For example, NEC Table 250.102 covers the sizing requirements for grounding electrode conductors and bonding jumpers. It is essential to consult the latest edition of the NEC and any relevant local amendments to ensure full compliance. The main bonding jumper is typically a conductor, often copper or aluminum, that connects the grounded neutral conductor to the equipment grounding system at the service entrance. This connection establishes a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. The appropriate sizing of the main bonding jumper is critical for ensuring that this path can safely carry the maximum anticipated fault current without overheating or causing voltage drops that could impair the performance of protective devices. When evaluating an existing electrical installation, it is important to verify that the main bonding jumper is not only correctly sized but also properly installed and maintained. The connection should be clean and tight, free from corrosion or other defects that could increase resistance and reduce the jumper's effectiveness. It is also important to ensure that the jumper is protected from physical damage and is not subject to excessive stress or strain. If there is any doubt about the adequacy of the main bonding jumper or the overall grounding and bonding system, it is always best to consult with a qualified electrician. A licensed professional can perform a thorough inspection of the electrical system, conduct necessary calculations, and make recommendations for any needed repairs or upgrades. In addition to the main bonding jumper, there are other important bonding connections that must be properly installed and maintained to ensure electrical safety. These include bonding jumpers for metallic water pipes, gas pipes, and other metal components that could become energized in the event of a fault. The NEC provides detailed requirements for these bonding connections, including the acceptable methods of attachment and the minimum size of the bonding conductors. It is important to note that the requirements for grounding and bonding can be complex and may vary depending on the specific application and the local electrical codes. Therefore, it is essential to have a thorough understanding of the applicable codes and standards before performing any electrical work. In summary, the main bonding jumper plays a critical role in ensuring the safety and reliability of electrical systems. Proper sizing, installation, and maintenance are essential for preventing electrical hazards and ensuring compliance with the NEC. If you are not a qualified electrician, it is always best to seek professional assistance when working with electrical systems. A qualified electrician can assess your specific needs, provide expert advice, and perform any necessary work in a safe and compliant manner. When considering the application of the main bonding jumper, firstly, review the electrical plans and specifications for the building or system to determine the design requirements for the grounding and bonding system. Secondly, conduct a thorough inspection of the existing electrical system to verify that the main bonding jumper is properly sized, installed, and maintained. Thirdly, perform calculations to determine the maximum unbalanced neutral load that the main bonding jumper is expected to carry under normal operating conditions. Fourthly, consult NEC Table 250.102 to determine the minimum acceptable size of the main bonding jumper based on the size of the service entrance conductors. Fifthly, ensure that the main bonding jumper is properly connected to the neutral bar in the load center and to the equipment grounding system. Sixthly, verify that all bonding connections are clean, tight, and free from corrosion or other defect. Seventhly, protect the main bonding jumper from physical damage and ensure that it is not subject to excessive stress or strain. Eighthly, test the grounding and bonding system to verify that it provides a low impedance path for fault current to return to the source. Ninthly, document all findings and recommendations in a written report. Tenthly, consult with a qualified electrician if there are any questions or concerns about the adequacy of the main bonding jumper or the overall grounding and bonding system. Understanding the specific requirements of the NEC and local codes is important to comply with regulations. The NEC is updated regularly, typically every 3 years, so it is essential to use the latest edition. Local codes may also have additional requirements that must be followed. Proper grounding and bonding are essential for protecting people and property from electrical hazards. The main bonding jumper is a critical component of the grounding and bonding system, and it must be properly sized, installed, and maintained to ensure its effectiveness. The consequences of improper grounding and bonding can be severe, including electrical shock, fire, and equipment damage. Therefore, it is essential to take these issues seriously and to ensure that all electrical work is performed by qualified professionals. To ensure ongoing safety and reliability, it is recommended to schedule regular inspections and maintenance of the electrical system, including the main bonding jumper and other grounding and bonding connections. These inspections can help identify potential problems before they become serious hazards. In addition to the NEC, there are other standards and guidelines that may be relevant to grounding and bonding, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards can provide additional guidance on best practices for grounding and bonding. The NEC also addresses the use of different types of grounding electrodes, such as ground rods, ground plates, and concrete encased electrodes. The selection of the appropriate grounding electrode depends on the specific soil conditions and the requirements of the local codes. The NEC also provides requirements for the installation of ground fault circuit interrupters, or GFCIs, which are designed to protect people from electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. The NEC also addresses the use of arc fault circuit interrupters, or SIs, which are designed to protect against fires caused by arcing faults. SIs are required in many locations, such as bedrooms and living rooms. The NEC also provides requirements for the use of surge protective devices, or SPDs, which are designed to protect electronic equipment from damage caused by voltage surges. SPD are recommended for all electrical systems, especially those that serve sensitive electronic equipment. The NEC also addresses the issue of electromagnetic interference, or EMI, which can disrupt the operation of electronic equipment. Proper grounding and bonding can help reduce EMI. The NEC also provides requirements for the installation of electrical equipment in hazardous locations, such as those where flammable materials are present. These locations require special equipment and wiring methods to prevent explosions and fires. It's also worth knowing that some jurisdictions may have specific requirements for electrical inspections and permits. It is important to check with the local authorities to determine the requirements in your area. If you are planning to make any changes to your electrical system, it is important to obtain the necessary permits before starting work. This will ensure that the work is performed in accordance with the applicable codes and regulations. When selecting electrical equipment, it is important to choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. This indicates that the equipment has been tested and found to comply with safety standards. Proper grounding and bonding are not only essential for safety but also for the proper operation of electrical equipment. A well-grounded and bonded system can help reduce voltage fluctuations, improve power quality, and extend the life of electrical equipment. If you are experiencing problems with your electrical system, such as flickering lights or equipment malfunctions, it is important to have the system inspected by a qualified electrician. These problems may be caused by improper grounding and bonding. The NEC also addresses the issue of stray voltage, which is a low-level voltage that can be present on grounded metal objects. Stray voltage can be caused by a variety of factors, including improper grounding and bonding. In some cases, stray voltage can be a nuisance or even a safety hazard. When working with electrical systems, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, or PPE, such as gloves and eye protection. It is also important to energize the circuit before working on it. The NEC also provides requirements for the training and qualification of electricians. Only qualified electricians should perform electrical work. Proper grounding and bonding are essential for protecting people and property from electrical hazards. The main bonding jumper is a critical component of the grounding and bonding system, and it must be properly sized, installed, and maintained to ensure its effectiveness. If you are not a qualified electrician, it is always best to seek professional assistance when working with electrical systems. A qualified electrician can assess your specific needs, provide expert advice, and perform any necessary work in a safe and compliant manner. Remember to always prioritize safety when working with electricity. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and other hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical safety.